on in-text questions. In that you see, we are given that find the focal length of a convex mirror. So first of all, we draw a convex mirror which has the inner surface polished. We have to find the focal length of this, and we know we will obtain the answer in positive. Find the focal length of a convex mirror whose radius of curvature is 32. We know that focal length is double the radius of curvature. So this is the value of radius of curvature. The answer is value is plus 32 centimeter. Now earlier we have done that the relation between these two, that the focal length is half the value of radius curvature. So replacing the value, I get 32 upon 2. The answer is 16 centimeter. In text question number 2, we are given that a concave mirror produces 3 times image. We are given the mirror here is a concave mirror. The outer edge is polished. Alright, it says that it produces 3 times an image, magnified image. It means the value of magnification is given 3. Now we know that when you talk about concave mirrors, then the value of magnification is taken as negative, -3. We are also given a real image of an object placed at 10 centimeter. The object is placed at a distance of 10 centimeter. Equal to curtain and convection, it will be -3. Now we are supposed to find where is the image located. We are supposed to find the value of V. Alright, so let's solve it. By the formula of magnification, we have -V upon U. Replacing the values, here magnification is given as -3. -V upon the value of U is given as -10. Now take this value on top. You get -V is equal to -3 into -10. Therefore V is equal to minus into minus plus. You get -V is equal to 30 centimeter. Therefore V is equal to -30 centimeter. It means that the image is real because it has a negative sign. It is in downward direction to the perpendicular, to the principal axis. Okay, it is located at a distance of 30 centimeter in front of the mirror. In the index question on page 176, we are given another sum. In the sum, we are given that light enters from air to glass. So let's draw the figure first. This is glass, that is air. Light enters from air to glass. What else is given to us? Having refractive index 1.5. So we can see here that refractive index of glass is given as 1.5. Then we are asked what is the speed of light in the glass. They are asking us the value of V here. Speed of light in glass. If the speed of light in air, the value of C is given to us as 3 into 10 to the power of 8 meters per second. Now relating these 3 values, we have a formula, and the formula related to that is the speed of light in glass is equal to speed of light in air upon refractive index of glass. So let's write the values. 10 to the power of 8 upon refractive index of glass 15. Removing decimal from here, we get 30 into 10 to the power of 8 upon 15. Cancel these 2, you get the answer as 2 into 10 to the power of 8 meters per second. So we can see that the speed of light in glass is 2 into 10 to the power of 8 meters per second. Moving to the next question. That's an in-text question on in-text 2 on page number 184. You can see that we are given a convex lens. In the convex lens, it forms a real and inverted image of a needle at a distance of 50 cm from it. So we can see here that the object distance, needle is 0, so object distance will be negative. and the distance of the needle is 50 centimeter. Now we have to find where is the needle placed in front of the concave lens. If the image is equal to size of the object. Now we know that in this, as the object and image are at the same distance, it means 2f1 and here 2f2 at C1 and C2. The object and image will be of the same size. Right? So we see that the value of V will also be minus 50 centimeter. So first we will find the magnification. Magnification is equal to V upon U. Okay. Now finding this will be positive, 50 upon minus 50, cancelling both, we get the answer as minus 1. So the value of magnification is minus 1 for convex lens. Now here we also need to find the power of the lens as well. So if we see here, then from this we can say that the value of image distance here is double the focal length, f1, f2. You can see here the value of focal length here is half of the image distance. It means the focal length will be half of image distance, 50 upon 2. Answer will be 25 centimeter. Now why have I done this? Because I have to find out the power of lens, and for the power of lens I need the focal length. This can be changed to meters by dividing it by 100. I get the answer as 0.25 meters. Now using the formula of power of lens, 1 upon focal length, it gives me 1 upon 0.25. Removing 2 decimals, I get 100 upon 25. The answer is 4 diopters. So in all, we have got 2 answers here. If the image is equal to size of the object, find the power. Okay, and that's it. First we have to find the focal length. For the power of lens, we have to find the magnification, and by the diagram we can say that the object distance and the image distance are same. Okay, it means the magnification is minus 1, and when they are laid the same distance, then the heights are also same. Moving to the next question, we have to find the power of a concave lens. So let's draw the concave lens. We have to find the power of this if the focal length is 2 meters. Now for a concave lens we know that rays go parallel to principal axis and they diverge. We have to retrace them to the focus. So focal length is taken as 2 centimeters minus 2 centimeters. We have to find the power of this. Alright, so let's take the formula. It is 2 meters, not centimeters. Let's set the formula. Relation between focal length and power is 1. P is equal to 1 upon f, 1 upon minus 2. Now this is already in meters. So dividing 1 by 2, you get the answer as minus 0.5 meters. Minus 0.5 meter minus 1. Why? Because this value is given as meters. When I take this value on top, it becomes minus 1. Minus 0.5 meters, or it can be written as minus 0.5 diopters, D. So this is the next question, that is numericals behind the chapter. According to us, the question number 6, we are given that an object of height 5 cm in length is held 25 cm from a converging lens. So please draw the converging lens. We are given that the height of the object is plus 5 cm and it is held at a distance of 25 cm. U is equal to minus 25 cm away from a converging lens of focal length 10 cm. So in this we see for a lens, the focal length is to the right. So we take it as positive. And we are also given, draw the ray diagram. We already drawn the ray diagram. Draw the ray diagram and find the position, size and nature of the image. If we see here, then the image will be formed to the right. Okay. And second thing to be found here is we will find the height of the image as well. Now using all the values that are given to us, we will use the length formula. Okay, so according to length formula, first we will find the value of V. So we have by length formula 1 upon V minus 1 upon U is equal to 1 upon F. Taking this value to the right, we get 1 upon V is equal to 1 upon F, 1 upon U. Placing all the values from there, we get 1 upon 10 plus 1 upon minus 25. Taking the LCM of 10 and 25 implies that. Taking the value of 10 and 25, we get the answer as 50. Dividing LCM by 10, you get 5. Dividing LCM by 25, you get 2. So the answer is 3 by 50. But this value is the reciprocal of image distance. So reciprocating this value, you get image distance is equal to 50 upon 3. When you divide both the values 50 by 3, you get the answer as 16.67 centimeters. So this is the first answer, that is the image distance that we have found. Now finding the height of the image. The formula for magnification of lens is height of image upon height of object is equal to distance of image upon distance of object. Replacing values out here, comparing only these two. Comparing these two values, we get h dash upon height of image upon height of object is 5. Image distance is, you can see from here, 16.67. Object distance is minus 25. So cross multiplying the values, we get h dash is equal to 16.67 into 5 upon minus 25. Solving this further, we will get the answer as minus 3.3 centimeter. This is the value for the height of the image.